Hey guys, this is Shelby with the Rogers Public Library. So this week's theme is kind of a continuation of last week, where we're going to be talking about gases again. So I hear a bottle, it's a glass bottle, and it has a balloon trapped inside. So this is a really cool thing that you can do with the balloon in a bottle. I'm going to talk about how I did it specifically in a little bit, but first I want to bring back out my model of the gases, right? So remember, when we talk about gases, we talk about the molecules in the gas. We also talk about the volume, which is the outside of the plate, or is it the size of the container they're in, and we talk about the pressure, which is how hard they hit the sides. There's another important thing that we need to talk about with gases, though, and that's how fast the molecules are moving. And so we can say how fast they're moving. We can say that's the average kinetic energy, kinetic movement. But there's, in the way that we measure average kinetic energy is actually through something called temperature. You guys are probably familiar with, that's how hot or cold it is outside. And that actually has to do with how fast the molecules of air are vibrating. It's just how our body experiences it. So this sounds a little bit silly. So you might be wondering, how do we know that that temperature is the same thing as molecules moving around? Well, this is an experiment that you can do to kind of demonstrate it. So I have hot water in here. I'm going to fill this one up. And this is just room temperature water, so I can put my finger in it without burning. This is pretty close to boiling, but not quite. So I'm going to put 1 drop of red food dye in the hot bowl and 1 drop of blue food dye in the cold bowl. And we're going to see how fast they move around. So, check this out. In this bowl, the molecules are moving around a lot. They're swirling. And in this bowl, the dye just sunk to the bottom. So, we can see from this that the molecules in the hot bowl are moving around faster than they are in the cold bowl, because the molecules are mixing out more in this bowl than this one. And so that seems like a pretty good demonstration of the idea that temperature is kinetic energy. They're the same thing. So this is called Brownian motion. And Albert Einstein actually wrote a paper about this. That's just a fun fact. So that's the principle that we're looking at here. But how it relates to gas, we're going to need to get a 2-liter bottle. Again, you can use a smaller bottle. And you're going to need a glove because you're pouring hot water and you don't want to burn yourself. I'm going to try to pour hot water in this container. It doesn't need to be all the way full. We just need to get a good amount. Okay. So I'm going to swirl it around and then dump it out. We don't actually want the hot water to be in there, and we're going to put the lid on. Now I have the hot bottle and I have a bowl of ice. And I'm going to dip it in there. I'm going to see what happens. So you can hear the sound of the bottle contracting. You'll look good from this angle. You should be able to see it in action. So what's happening is that when it got hot, the molecules inside it started moving faster and taking up more space. But when we put the lid back on, it traps that number of molecules in there. And as it cools down, the molecules stop moving as much and they take up less space, and that causes the bottle to crinkle in on itself. So that's actually the same thing that happened here. I put hot water in this bottle and then I tipped it out and put the balloon on the top. Now the difference between these two is that if you put hot water in a glass bottle, you don't want to dip it in ice water right away because it can shatter and you can get hurt. So definitely don't do that. If you do this, use a plastic bottle, or if you put hot water in a glass bottle, let it cool down on its own. So it's going to be slower and less exciting, but you will have a balloon trapped in a bottle and it looks pretty cool. So for this craft, it can be a little bit messy, so you might feel more comfortable doing it outside. Because we're doing this inside, I'm making sure I lay down a plastic tablecloth, as well as a tablecloth behind it just to catch any paint splatters. But basically what this is a marshmallow launcher. So it's a rubber balloon that I put over the top of a cup, and I get a hole in the bottom, and you can go like this and you can launch marshmallows, or you can launch paint. And I'm going to be doing the latter here. So this actual science of how this works, I kind of go into this more depth in my watermelon video, but it's actually pretty similar to how the gases work, right? There's a relationship between the pressure, or how much you pull on it, and its temperature. So when you stretch it out, it gets hot, and then as it decompresses, it'll cool down, which you maybe won't notice this like in a balloon or something, but you can see it pretty well if you have a spray can of something. But I'm going to take some tempera paint, and we're using tempera paint because it cleans up pretty well. So if we do spill some, it'll be fine. And I'm going to stretch out the bottom. Woo. And you can do this as long as you are content. You don't have to use a different cup for every color because the colors are going to get mixed up anyway. So, woohoo. One thing to note though is you're getting a lot of paint on your paper. So you're going to want to use a very a thick paper. This is like, it's got a little bit of cotton in it, so it's pretty thick. It's going to it's durable, and it's not going to get messed up because we put too much paint on it. But you can also use special painter's paper, or you can use cardboard or a canvas if you have that. I'm going to put a little bit of green as well. And the harder that you pull back on this, the smaller that the paint will be, because it's moving faster. If you pull back very little, then it's going to kind of splotch like that. But then you have to balance that, because if you pull this too far, it's going to come undone, and then you're going to get paint all over yourself, and that won't be fun. But that's our craft for today. Hope you guys had fun. I'll see you next Thursday.